Hi students, let's look at this question here, which is on vectors taken from the year 2001 of the H2 Math A-level paper, to question 15 part B. Alright, so by expanding B minus C, dot with B minus C, simplify this expression here. Okay, great. So the first thing you must be able to tell as a H2 Math, if a student taking H2 Math, is that when you are given two vectors being dot by itself, you need to know that this is actually equals to modulus b minus c square. Okay, that's the first thing usually I tell my students to be mindful of. So essentially what we know is from our dot vector dot product, we know that a dot a is mod a square. Alright, so or b dot b is equals to mod b square. So similarly, if you have b minus c dot with b minus c, you have to be able to tell that these are equal. If not, you probably will miss a point. So I have not seen the subsequent part. So this is what this is the first thing that comes to my mind, which is to know that the dot product is the modulus b minus c square. So by expanding that, so I'm going to just expand that. So by expanding this, so I'm going to just expand this out. So we know that the dot product, we can just distribute it, and this would be b dot b plus b dot minus c plus negative c dot with b, and we could just slowly do it. This is minus c dot minus c. Okay, so the scalar, this was just b dot b, of course this is mod b square. We know that b dot b is mod c b square, and this is c dot c actually, but I'm going to just slowly do this. So this is b dot c minus c dot b. We know that b dot c is equal to c dot b, so this could actually just sum them up. Okay, so this plus mod c square. I'm just going to skip a step here. So this is great. Once we're done by expanding this, that's what they asked us to do. Then this case here, what I get is b dot c and c dot b. This will just be minus 2bc, right? Plus c. Then we just need to rearrange, because what we need now is actually simplify this expression here. So this expression has got mod b square plus mod c square and minus of this one on the right. So this is just b minus c dot b minus c. And what we get is actually just to just rearrange them, equals to mod b plus mod c square minus b minus c dot with b minus c. Okay, so I think that is pretty okay, this question here. Not to say, so hence, this simplifying this will just be, actually this is just equals to this now. Okay, simplifying it, so hence, this, maybe I just write this on the other side, mod b minus c dot with b minus c equals to b dot c. Okay, that's how you simplify this expression here. From here, we are told by taking b is a to c and c is a to b, deduce the cosine formula of ABC. So just draw the triangle out. If you are not very sure, just draw it out. This would be a and b and c here. Alright. So a to c is b. So this is a to c. This over here, we are given that this is b. And a to b is actually c. Okay, so cosine formula, of course, the angle is very important. Cosine formula will be this juncture here. Okay, so first thing is this angle here, the angle between B and C. The first thing is understand that, understand all the terms here. So this length here of the triangle is obviously mod B, right? Because modulus B is just the length of the side, and this same thing here, this will just be mod C. Okay, so we just write it down. This will just be AB, the length of AB is just mod C, and the length of AC is just mod B. Great. After which we have this weird stuff here. Now this is where I say usually what I tell students to understand is when you take two vectors, you dot them by themselves, they will get the modulus of themselves. So B minus C is actually, if you look at this diagram here, B minus C, so you have minus c here, and then plus a b here. Okay, we actually get b minus plus minus c, b minus C is actually B to C. Okay, this is important. This is important. Or you could just see this as, yeah, B minus C. Am I right? A to B is C. A to C is B. Okay, great. So yes, B minus C is actually just this opposite direction, minus B plus B. So minus C plus B is BC. So in other words, we have got B minus C is equals to BC. Okay, that is the very important part. Now then, after which you know as well that from the previous part, we need to find B dot C, right? B dot C. So B dot C, we are looking at this angle here. So it's we know that B dot C is just using the cosine formula. I mean the dot product. This is B C cosine theta. Okay, so what I did was I just gather all the things that I need. I have this and I have this, and of course I have this as well. I know that this initially this is B minus C modulus 2. Then this is B dot C, right? So we got this formula here. So what I'm going to do is actually going to try and just see how do I make sense of all of this. So this case here, what we get is, what we will gather is from 1. Okay, so this will imply, okay, B minus C dot with B minus C is just modulus of BC square. Okay, essentially just BC square there. So from 1, substituting sub all this expression here, sub AB equals to mod C, AC equals to mod B, B dot C equals to mod B, mod C cosine theta, and B minus C dot with B minus C equals to BC square into 1. What we get is actually AC square, so this is AC square, plus AB square minus BC square minus equals to 2 mod B mod C cosine theta. Okay, so there you go. This is a pretty interesting. So BC is here, so this is, we need to make this a subject. So BC square is equals to AC square plus AB square minus 2 mod B mod B mod C is also equals to, mod B is actually just AC and mod C is actually just AB cosine theta. Okay, so that's how you do this question here proficiently. If you have any questions or comments, or please let us know, and I'll see you in the next question.